Okay, so graphs of the other four. So anyways, we're going to start with tangent and cotangent. But what I was saying to the class is that A, B, C, and D all still do the same things. And these two you're going to see are closely related, and then we're going to do secant and cosecant. And again, bx minus c plus d. All right. So they are all cyclical. So there's some repetition. But what we're going to see is, do any of them still look like waves? And I think we're going to come up with that answer pretty quick. So let's start with tangent and cotangent. So I'm going to do the same thing with the t-chart. And let's just go negative 2 pi to 2 pi with our t-chart. And what was it that we used to help us get all of our values for sine and cosine? Like when we wanted to get the outputs, what did we use? The unit circle. Like you can just be half asleep and just say, either say draw a triangle or unit circle, and you're pretty close in trig class to being right, okay? So we're gonna get all the outputs for tangent, and let's use our unit circle. Now, how do you do tangent though? How are we gonna use the unit circle to get the tangent? What's tangent equal? How do you do?
Opposite over adjacent.
Yes, but remember we're using unit circle, so we got these 4 points. So like for angle 0, we know the cosine of angle 0 is which of these coordinates? The x. So we know cosine of the angle is the x. This is only on the unit circle, right? And sine of the angle is the y. All right, this is the shortcut that we're using. So if I want tangent, how am I going to get tangent? Y over x, because remember it's sine over cosine. So since it's sine over cosine, we're going to do y over x. So if you do y over x, that will give you tangent. Okay, so use your points here. I'll label the points. You should know the angles that go with each one of these points. And go ahead and do y over x, and you should be able to get each one. I usually start at 0 and go that way and go counterclockwise, and then I go this way and go clockwise. So for instance, this is pi over 2, but this is 3 pi over 2. This is also negative pi over 2. Okay. All right, go ahead and get that, and then we're going to plot this on the xy plane over here. What are they recruiting you as? A defensive back, or just an athlete? Good. Can you catch the ball?
Yeah.
I was gonna say you could be like those flankers that, or the guys that come in out of the slot. I don't know if you do that also.
Yeah. So that's one of my positions. Yeah. The video.
Yeah. That way you have more options. Okay, ready? Should go pretty fast. It's once you see the pattern, it's either, what are your answers either? Your answer is either what or what? 0 or undefined. So when y is 0, your output is 0. When your x is 0, you cannot divide by 0, but we put what answer? Undefined. Okay. So I point, you tell me the output, 0. 0, right? Pi over 2. Undefined. Pi. 3 pi over 2. Everybody with us on how we're getting this. So we're going to 3 pi over 2. Tangent. So let me just show the work here. Tangent of 3 pi over 2 means we're going to do sine, which is -1 over cosine. Dividing by 0 is undefined. And then back to 2 pi, since the y is 0, 0 over 1, we get 0. And then go back down here to -pi over 2, that's undefined. Then you know what's happened on each one. 0, undefined, 0, undefined, 0, undefined. So if negative pi over 2 is undefined, what's negative pi going to be?
0.
3 pi over 2. Negative 2 pi. All right, so 0 you plot, you're just putting, that means it's a root. It means it's on the x-axis. So if the output is 0, what we're going to do is at each of those points, I'm going to put the point there on the x-axis. Negative 2 pi, negative pi, 0, pi, 2 pi. Okay, now we need a quick refresher. I don't have much room here, but we'll put it right here. Do you remember earlier in the year we studied this type of function? For plus 500 minus 500 bonus points, can you give me the name of the family that this function comes from? The blue equation here. Rational function. It is a rational function and it has blank behavior. Asymptotic behavior. It has asymptotes. It has horizontal asymptotes and it has vertical asymptotes. Do you remember how to figure out where the vertical asymptotes are? Let me get CJ.
When the bottom equals 0.
What makes the bottom 0 here? 2. So for instance, we know that there's going to be a vertical asymptote at x equals 2. Why? Because y of 2, if we sub it in, we get 1 over 0, which is undefined. So if an input makes only the bottom 0, we get undefined, and notice that's where the vertical asymptote is. So go over here. Take our pi over 2. Basically, we're getting tangent of pi over 2, which is sine of pi over 2 over cosine of pi over 2. And the top, it makes the top 1, but notice it makes the bottom 0. So since pi over 2 makes the bottom 0, that's going to be undefined, but graphically that's the location of a what? Vertical asymptote. So all those other places where it's undefined, those are all asymptotes. So at each one of those, so pi over 2 asymptote, 3 pi over 2 asymptote, negative pi over 2 asymptote, negative 3 pi over 2 asymptote. So here's what I want you to understand. For tangent, at all the n pi's, pi, 2 pi, negative 2 pi, 3 pi, 4 pi, negative 3 pi, negative 4 pi, they're all zeros. See? Because that's where sine is 0. And all the half pi's, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, that's where it's asymptotic. Okay? So now we said waves. Well, we got a problem. Asymptotes represent what in the graph? No, they're not holes. Holes is a whole different thing. You got the right idea, but it's not a hole in the graph. It's a what? It's a limit. It's a boundary. So therefore, the graph cannot go through this. So this point that we have in here, this graph is going to be bounded in here. It can't cut through this. And then there's going to be a piece that's bounded in here. So these act as boundaries. And remember, the other word I use is guides. It tells you where the graph is going. So if we need more information, because right now I've got a bunch of dots. So what we're going to do, let's do this. Let's pick a value in here and in here and see what the output is. And then, so for instance, if I get a positive output, I know it's going up. If I get a negative output here, I know it's going down. What would be a good angle to pick between 0 and 90?
45.
45. So we'll do pi over 4. Now, once we go to pi over 4, so now we're going to have to find tangent of pi over 4. I can't use the units. I could, but I'm just going to use triangles now. So now I'm going to use pi over 4. And then what about here? What would be another good x? What do you think? There you go, negative pi over 4. So how do you find pi over 4 and negative pi over 4? If you want to do tangent of it, what's the process? I'll give you a hint. I wrote a long recipe for it. It's your recipe. You got to use triangles now. See, I only use the unit circle for these angles, for the quadrant angles, the one that are on the axes. If I have pi over 4, which is what degrees? What degrees is pi over 4? 45. So if I want to find the tangent of pi over 4, right, because I've got to use my chart here, then I've got to draw a 45-degree angle and go through my SOHCAHTOA. So I'm not gonna use the unit circle. I'm just gonna use the axis and draw the angle, okay? So 45 puts us in which quadrant? First, there's 45. All right, then we drop our perpendicular. Label your sides and then do tangent. And then negative pi over 4 is gonna be negative 45. That's gonna be this one. Okay? And then do that, label your sides and do your, how do you do tangent? What's the SOHCAHTOA for tangent? You said it earlier. Opposite over adjacent. Very good. All right, go ahead and take 2 seconds and get those outputs. The answer is important, but more importantly is the sign of the answer. SIGN, is it positive or negative? Okay, so let's see. Tangent of, all right, so for 45, what's the legs?
1 and 1.
1 and 1. They're both positive? Yeah, in the first quadrant. I don't even need the hypotenuse now. So what's the tangent of 45? 1. Now, you can go ahead and put that, but I'm going to tell you, I don't really need that point because all it's doing is, now I just know the graph is doing that. Okay. All right, negative 45. So let's see. So we still have this as 1, but now we're in the fourth quadrant. So what's the y leg? Negative 1. So tangent of 45, we got 1. Tangent of negative 45, we get negative 1. Okay. There's that. It does this. So what graph does this kind of resemble? If you were going to say it looks like something, what does it look like? Yeah, maybe x cubed. The difference is x cubed goes this way forever, and this one now, it cannot cross this asymptote. So x cubed would keep going that way. Now, what do I do though? Because now I've got all these other, well, what's happening here? What do you think is happening? The exact same thing. Now, notice, so we could test points again, but what you're going to see is it's doing the same thing. Let me give you an easy way to do this. Look at this. Does everybody remember this? What's the saying? Okay, so 0, pi over 2, pi, 3 pi over 2. Now look, so from here to here, 90 to 180, what's tangent going to be? So from pi over 2 to pi, if I draw an angle there, what's tangent? Well, if there's no t here, it's going to be what? Negative. So I know that output is negative, see? And then from pi to 3 pi over 2, this here represents the angle here. What's tangent in the third quadrant? Positive. So since it's positive, it's going to be here. There you go. And you can see the repetition there. And it just does that forever. So since I've got 2 pi, I go here. Negative pi, I go here. So it's just this piece over and over again. Okay? And I stopped, but if I wanted to finish this picture, where would the asymptote be here for this one? Very good. 5 pi over 2. That's where your asymptote is. Then you finish the picture. Okay. Now, a couple of things. Here's what I want you to see. Is it cyclical? So is there repetition? Yes. How often does it repeat? Every what?
Every cycle.
Right, but like what would be the x distance for how often it repeats? So from here to here, like with sine, it was 2 pi, right? We had to do this, right? For sine, we went like this. Here, yeah, let me draw it. So, yeah, there you go. Hill, valley, that was 2 pi. Then we did another hill, valley, another 2 pi. So the cycle for sine was 2 pi, because it took it 2 pi units to repeat. How far in the x direction before it repeats again? Pi. Tangent is pi periodic. I just look right here. 0 to pi. Pi. Pi to 2 pi. Pi. So tangent is pi periodic, not 2 pi. Okay? So that's important. So we're going to make a note of that. All right. So a couple of things. Let's now, all right, what would be what do you, remember I used what's the computer words I use for graphing? When you want to graph one of these, it's impossible to draw the whole graph because it does this forever. So copy and paste. Which picture would you want to copy and paste forever? Anybody want to take a stab at what you think we should keep? So for instance, I need something that I just keep repeating over and over again, that I just copy and paste forever. Does anybody want to take a pick of what you think we should use? So first of all, how long does it need to be? Pi, because we need at least pi, right? Because that's the repetition. But how would you describe this? Like, what would you say is happening over and over? Just tell it to me in words. If you wanted to describe what you're seeing here, what would you say is happening? There are what, and then there's what in between it. That's how I would describe it. There's two what? Asymptotes, and then what's happening in between it? Yeah, just a squiggle, right? That's it. I need that picture over and over again. So pick one.
Maybe pi 2, you said pi 2.
That's the one I would use. I would use this one here. I'll highlight it in green. That's it. There's my one cycle. Because negative pi over 2 to pi over 2 is pi. And if it's that picture, because that's what you want to see. And then you just paste it again here. Now, yeah, this asymptote would be here, but yeah, I mean, I'm still, at least I know that's the picture over and over again. So that's what I would use as one cycle. So for one cycle for tangent, one cycle is this. So we're going to go negative pi over 2 to pi over 2. And we're going to draw the squiggle in between. Now, it has period. So the period, what was the formula to get period for sine and cosine? Do you remember for any sine or cosine function, what was it?
2 pi.
So since the period for tangent is pi, it's going to be pi over absolute value of b. Get the b in front. It won't be 2 pi because tangent is pi periodic.
Oh, so you put the cycle over there. Absolute value of b.
Yes. Well, on sine, we did 2 pi over b.
Yeah.
This one's pi over b because this is pi periodic. Okay. So for instance, if I said, what's the period of tangent of 8x, and we want period, we would say the period is pi over what? 8. There you go. Pi over 8. Everybody see how we got that?
Yeah.
Okay? No?
Wait, how'd you get 8?
B is 8. Pi over b. B is the number in front of x.
Wait, what? How'd you get 8x?
I just made this problem up.
Oh, you made it.
And I asked you, how would you get the period? Yeah, no, it's okay. I'm just saying, if I give you an equation, how are you going to know the period? It's pi over the coefficient of x will always give you the period. Okay? All right. So let me ask this. Is this a wave? No, a wave is this. It's not a wave. Number two, since it's not a wave, does it have amplitude? No, so there's no amplitude. But there's a fancy word. There is periodicity because it repeats. So you can find period, but you will not get an amplitude question. Notice when you did your graphs on the sine and cosine, it was pretty nice. If you just typed in the information, it drew the graph for you because it would say what? What would it say? Like amplitude, you would type it in. Period, you would type it in. It would say, where does it start? Right? I think you had to do your phase shift in there somewhere. Or a horizontal shift, vertical shift. You type it all in and it drew the wave. Now, let's see what else is going to be different. All right, let's just say I wanted to graph this, tangent of 8x. I want to see now what happens to this, see? So what was it we did for sine and cosine with the bx minus c? Remember the bx minus c when we had sine or cosine? What did we do with this in order to see the phase shift? We said bx minus c equal to what?
0.
And we said bx minus c equal to? Why did we pick 0 and 2 pi to set it equal to? That was the beginning and end of the sine graph. See, because now what I'm trying to do is every time we develop one of these, I want you to see what the differences are. So for tangent, we're going to do pi over b, right? We'll work this problem in a second. And then now, how do we do the shift, right? How are we going to do that horizontal shift? Well, since that's our picture, since this starts at negative pi over 2 and ends at pi over 2, if I have tangent of bx minus c, I'm going to take bx minus c, set it equal to, no.
Negative pi.
So again, time out. Why did we set sine to 0 and 2 pi? Because that's where the sine wave started and ended. We picked 0 and 2 pi because that's where that wave, that was the old start, and that was the old end. And we were trying to see where did those points move to. So here, on one cycle, it starts at negative pi over 2 and ends at pi over 2. So we're going to take bx minus c, set it equal to negative pi over 2, and we're going to take bx minus c, set it equal to pi over 2. So I just want to show you real quick for tangent of 8x, right, that we should be able to graph that using the same idea, okay? So I would take 8x and set it equal to negative pi over 2, and I'm going to take 8x and set it equal to pi over 2. Because this is how I'm going to get the new start and new end. And then now we're just going to copy and paste. So don't overthink this, guys. Look, like a lot of times students get here and they see fractions. What are you taught to do with 8? Andrew, I was just like asking, I don't know, you always look like you're deep in thought, so I want to see what you think. What were you taught to do with 8 when you solved this? Like, I want you to solve this equation. What do you do with 8? All right, that's what you were taught. I don't like that. Because this is why I don't like it. That looks awful. Look at the right-hand side. That just looks like just not fun, right? So I teach my 8th grader who's doing this stuff now, we don't divide. Although we multiply by the reciprocal. What's the reciprocal of 8? 1/8. 1/8. That's much better. See, now I've killed 2 birds with 1 stone. Now I'm ready to just multiply here. So we get x is negative pi over 16. Boom. All right, so Molly, what should we do here? How do we solve now? Yeah, multiply by the reciprocal. That's gone. That's gone. We get pi over 16. So now what has happened? Well, now we know where to copy and paste. Now look, pi over 16 is, if I was going to do this to scale on here, pi over 16 is way in here and there. So remember, what's a way I don't need to overthink this. I need to draw that picture from negative pi over 16 to pi over 16. So all I'll do is draw my axis. Where's negative pi over 16, right or left? Left, so I'll just go somewhere, negative pi over 16. And I go right the same amount. And then how do we draw a tangent? Start with an asymptote, end with an asymptote, then you put the squiggle in between that approaches. Always put your asymptotes first, because that way you know your guides. And there you go. All right, what would the A do? Stretch it or smash it. So you would stretch it or smash it. What if it's negative? Rotisserie chicken. What if you have a plus D? Oh, so you would take this as the only point really that I plot, and that would move up or down. All right, so all I'm introducing is, so what we're going to do, I'm obviously my board, because I'm taping this for at home, we'll wait. So in your notes, you should have this right there for tangent. There's your cycle, that's how you get period, and that's how you get the phase shift, right? Remember, this is still your phase shift. Since this is not a wave, I don't know if we use this terminology, phase, I better reread. But you get the idea, to see where it moves. All right, so you store that, and then at the end, we'll collect all these. So here's what we gotta do. We gotta do this, all I'm trying to do is do this for the next 3 graphs and then stop today. So I've introduced it, and then we need to do more practice with it on Monday. But do you think you have enough knowledge? You could go in and mess around a little bit. I think so. Okay, so that should be in your notes. Here's our period. Here's our 1 cycle. This is the period. This is how we handle the horizontal shift here. Okay, I didn't do A and D because those do the same things. Okay. All right, so what's next? Cotangent. All right, get started. How are you gonna get the outputs for cotangent?
Reciprocal was in tangent.
Very good, reciprocal of tangent. So if tangent was y over x, what's cotangent gonna be? X over y, very good. All right, so we're gonna do y equals cotangent x. What are we looking for? I mean, when we graph this whole thing, we're in search of what? What's gonna be our what? Copy and paste, our cycle. We're looking for our one cycle, copy and paste. So do all those, use your unit circle. I'm not gonna put it on the board again. You should know, you should have your unit circle. Essentially, what should happen to all your undefines and zeros, do you think? They should switch. It's gonna take you 2 seconds, okay? We'll do a couple and then that's it. So I'm not gonna put the unit circle there because we're doing cotangents, cosine over sine, or the x value from the unit circle over the y value. So all I want to do collect today is let's pick our one cycle. And we're going to come up with what is happening with the graph without doing any triangles. I think we can use common sense or math sense to figure it out. Remind me, I have a Zoom at 11 with our buddies at home, okay? I didn't set my alarm, so I'll forget. But I'll remember the CJ's got his thing. Okay. What did you get for cotangent of 0? You should get undefined. And then from there, just flip-flops. Pi over 2 is 0, pi undefined. 3 pi over 2 is 0, 2 pi undefined. Let me just work one of them out. So like, for instance, I want to do cotangent of 0. It's going to be the cosine of angle 0 over the sine of angle 0. So on the unit circle, angle 0 is here. Here's our unit circle. This is the point 1, 0. Cosine is the x, sine is the y, and that's how we're getting undefined. Obviously, I don't want to do those over, show all the work. That's just for you guys and for the ones at home. And then we see it flip-flop. So negative pi over 2, we should get 0, negative pi undefined, negative 3 pi over 2, 0, negative 3 pi undefined. So I'll go ahead and put those asymptotes in. So same idea, all the asymptotes is undefined. Okay. All right. So it should have flip-flopped. And all the pi's, 2 pi's, negative pi, negative 2 pi, even 0, that's where our asymptotes are. I'm going to figure out which way this is going without using triangles. Let's think for a second. What's this x right here that's in between these two? Yeah, pi over 4, okay? Now, since cotangent's the reciprocal of tangent, wherever tangent is positive, that's where cotangent is positive, because they're reciprocals. So rather than so this right here, x's in here correlate to angles here. So what's cotangent going to be for a first quadrant angle, positive or negative? Positive. Well, what answer should it be? For 45 degrees, what should cotangent be? 1. It's positive, so notice it goes up here. All right. Now, pi over 2 to pi represents what quadrant? What angle quadrant? Pi over 2 to pi. Second. Pi over 2 to pi is the same as saying second quadrant angle. Well, look, there's no t here. So what's tangent in the second quadrant? So if tangent's negative, what's cotangent? No, they're reciprocals. If you flip a negative, it's still negative. When you flip, you don't lose the negative. So therefore, any output for cotangent has to be negative. And there you go. So you're getting the squiggle, but how are you getting the squiggle? Reverse, flipped, right? Decreasing. So we're just gonna repeat that over and over again. There you go. That is your cotangent graph. This is cotangent. Okay. All right. What would we pick as one cycle? What do you think?
0 to pi to pi.
0 to pi. That's what I would pick. Again, because what do I want? I want an asymptote, a squiggle, and an asymptote. So, I agree. I would use 0 to pi. All right, there's going to be our one cycle. How far before it repeats again? Spencer? How far in the x direction and pi? So it's cotangent, just like tangent is blank periodic. Pi periodic. Okay. Good. All right, so there you go. So we went through this one a little quicker. All right, now that we have gained some knowledge. So we're going to do cotangent real quick over here. So we're going to go 0 to pi. Oops, I don't put brackets because we can't reach 0 or pi. So one cycle looks like this. 0, pi, in between, we put a squiggle. Oops, there's that. So what's the period for cotangent? What's the period we need?
Pi.
Pi over, yeah, but for all of them, pi over
Absolute value of b.
absolute value of b. Okay. So the last thing I want to go through is, again, so can I erase the big graph? We got that. Okay. How do you handle the, I'm only handling the bx minus c. Okay, I just want to talk about that right now. So if I have cotangent of bx minus c, let's just say we have y equals cotangent of 4x plus pi, how would we handle that? See, what would we do with bx minus c for cotangent? We should take bx minus c, set it equal to what and what? So take the thinking that we've used on the other problems, and what would you set the inside equal to? 0 and pi. Very good. Because that's where this starts and ends, and we're trying to see how these translate. And that's what we'll solve for. So real quick, let's graph this. And let's just do this, just a basic. Notice I'm not doing any flips or anything. I'm not doing any vertical shift. So let's sketch this one real quick, just to see if you can sketch it. So we're going to take 4x plus pi, set it equal to 0, and 4x plus pi, set it equal to pi. Let's see what happens. Okay. See, it kills two birds with one stone. It takes care of our horizontal stretch or smash and our horizontal shift. It should still be phase shift. I promise I'll be done before 11. If this goes until 11, I'm going to cry. It's a long time to do a lot of trig stuff. Okay. What did you get? Very good. Subtract pi. So 4x is negative pi. So x is negative pi 4. So when it asks for horizontal shift, that's what you get. So I'm assuming you figured out how to type pi in on your, because you don't have a pi, you know that little pop-up box that comes? How do you put pi in if you don't have a pi symbol? Pi, capital P, lowercase
Well, I
I.
just copied and pasted because I couldn't figure it out.
Oh, is that what you did?
Yeah.
You just type capital, yeah, well, that's where you asked me. That's where you shoot me a quick email, hey, I can't figure out how to do pi, and I'll help you, okay? It takes right 2 seconds. But you do capital P, lowercase I, you type it in, then it changes it to the pi symbol. It's not P-I-E. I know we like to eat pie. It's P-I, the Greek letter pi, okay? And then what happens here? When I subtract pi, I get 0, so that means it's going to end at 0. It's okay. So this graph shifts which way? Left. And what else is happening to it horizontally? Smashed. So smaller. See, look, your cycle is only pi over 4 now, which should make sense because how do we get period? Pi over, 4, pi over 4. So if we want to graph this, negative pi over 4, 0, and then remember it's a downward scribble. But the computer is going to do that for you. I think you'll just, once you type that in, you should be good. It's going to ask for horizontal shift. And then it should plot it. And then it will put other cycles for you, which is nice. Okay, there you go. This should be in your notes, along with this. So are you getting the gist now of how to do, what's the word I'm looking for? Of how to do the phase shift. You got to know where your cycle starts and ends, and that's what the inside's set to. So really, once you can do that, you can do any of them once you have the basic graph. Now, I like to do cosecant before secant. So we're going to do, I know it sounds counter, but we're going to do cosecant first, okay?
So basically, when you get a new phase shift, it's just the points of the new asymptote for that one? Okay.
Yeah, well, technically, your phase shift is the first one, because that's telling you horizontally, where does it move to?
Yeah.
But yeah, when we do this, so yeah, it's telling you, because that's what starts and ends this. So since that's the start and end, so basically, think about this, if it's a computer, I'm pasting it here and then I'm adjusting my window with the, like, that's all we're doing. Okay, so we're gonna do cosecant next. All right, so you should have each one of these that I'm circling at the end, that needs to be highlighted. Some of you I know like to use that. Hey, I'm going to leave our x, y, or yeah, our x and y here. So we're going to do cosecant now. So now, how do you do cosecant? Cosecant is equivalent to what? Very good. 1 over sine. And so that's going to be 1 over the what value from the unit circle? 1 over the y value. Because sine is the y value. So we'll use our unit circle, but now you got to remember that you're doing 1 over the y for each one, because that's sine. Okay? So go through it fairly quickly. See if you can get all your points. I would start at 0, so let's do the first one together. If I'm going to do cosecant of 0, it's 1 over the sine of 0, and sine of 0 is 0, so I'm dividing by 0, so I get undefined. Right? If I do pi over 2 with you, cosecant of pi over 2 is 1 over the sine of pi over 2, which is 1 over 1, which is 1. And then keep continuing from there. So let's see what you got. So now we got different, now we're getting one, and what's the other number you're getting for an output? -1. You should never get 0. Why can't I get 0 for an output? Can somebody tell me? Mathematically logical, why can you never get 0 for an output? Your numerator is 1. Never get 0. The numerator has to be 0 to get 0. So yeah, same idea, but yeah. All right, you tell me, I'll point. So 0 is undefined, so we're gonna go ahead and put a what? Asymptote. All right. Pi over 2, you got what? 1. So now I gotta plot that. Pi, you got what? Very good. Asymptote. 3 pi over 2, you got what? 2 pi, you got what? Asymptote. So it should flip-flop. So at negative pi over 2, you should got, I think, -1, right? And then negative pi is an asymptote. Negative 3 pi over 2 is 1. Negative 2 pi is an asymptote. Now, the question is, what's happening at these points, right? What's happening from here? We need more points. This isn't enough. So remember, asymptotes act as what? Boundaries and guides. The graph is going to approach it. So let's think real quick. Pi over 4, like, would be here. So if I wanted to do cosecant of pi over 4, the question is, do you think the graph is going to go up or the graph is going to go down from that point? What do you think is going to happen? What did we just say, Spencer? We just said that cosecant can never be what?
0.
0. Well, you have two choices. Has to go up. You cannot go down because it cannot be 0. Now remember this. If cosecant is take normal sine, like ratios for sine, half, square root of 3 over 2. Those are all less than 1. If you reciprocate something that's less than 1, it now becomes greater. So we got to go always bigger. So it goes here and here. It's like these parabola-looking things. Okay. Now when I go here, same idea that we just said. It cannot be 0. So we got to go which way? Down. Down. Up. Now see if you can pick what you think is one cycle. Be a little bit more, don't be too quick to give your answer. Think for a second, what is the copy and paste? Right? What is happening? All right, Molly, would you like to tell us? Very good. Because what's the cycle? Asymptote up, asymptote down, asymptote. See, it's not just this. If you copy and paste this for everything, you should all just have up. You gotta have an up and a down. And then I would do exactly, because look here. See, it's the same picture. That's why I did this one first. She's exactly right. Okay. Now, while we're here, real quick, well, we'll just wait. I'm not gonna do that just yet. All right, so let's do this. So for cosecant, we're gonna go 0 to 2 pi. So now our one cycle is 0, pi is the middle, 2 pi is the end, and then now you have this 1 and -1. You have these, what do you call it? Parabolas. They're not parabolas, but they look like it. Okay. Now, so let me ask you this. Oh, what do you think is the period formula going to be for cosecant? 2 pi over b. Back to 2 pi now. Okay. We'll get to phase shift in a second. We'll handle that. Let me ask you this. What is a number in front going to do? Let's just say I had 3 cosecant x. Now, what do you think that 3 is going to do? Yes, it's going to vertical. So this dot here should now be at what? 3, right? And it's going to go there. And then this dot here should now be at -3. So it's going to really stretch it apart like that. So you have a bigger gap, okay? So it will really stretch it. It actually moves, it has to move because that's the lowest point there. That's what will happen, yeah, okay? But we're gonna do more of that on Monday. I'm just touching base on it real quick. Now, let me show you this before we do anything else. In a second, we'll do the bx minus c. What do you think we're gonna set if we have, so if we, remember, if we have a cosecant bx minus c plus d, a multiply all y's by a, so we did that. What do you think is gonna happen with bx minus c? We're gonna set it equal to what? 0 and, very good, 2 pi. All right, so at this point, I'm not gonna keep working those since we know that now, all right? Now, let me show you this. What is cosecant the reciprocal of? What is cosecant the reciprocal of? One more time, louder. What is cosecant the reciprocal of? Ready for a magic trick? See? I know, I'm a magician. So look, the reciprocal of 1 is still 1. The reciprocal of -1 is still 1, but think with reciprocal, see how it flips. And then think, where sine is 0, right? Look here where sine is 0. What happens to cosecant? Everywhere that sine is 0, cosecant becomes, because you flip 0, you get undefined. So if sine and cosecant are reciprocals, guess what I'm going to do to graph secant? I'm going to use what? I'm not going to do all this mess. So you might even want to take a picture of this, thinking about that this is the sine graph is kind of fits inside of cosecant. You might want to draw this picture, add this there if you want. Okay? And now to do secant, I will not do any of these values. We'll go straight to graphing cosine and then flip to get secant. Okay? Does that, everybody see how that works there? So notice where the peak and the valleys are for sine, that's where these little parabola things come from. All right, so let me erase this so we can do secant and cosine and then we'll be done. We'll collect our one cycle. Now notice, I think you did a great job picking your one cycle here, right? Going to be pretty, but you're going to have to do 3 asymptotes, start, middle, and end when you do your shifting. Again, we'll do more of this on Monday. Okay? All right, so so here's how I'm going to graph secant. I'm going to graph secant using this same thinking. All right, and the thinking is this. We're going to graph cosine first. All right, video, closer. All right. All right, let's graph cosine first. So I know it's here, right? It goes there, 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 there. Let me do this one in pink. All right, and then it's going to go here, 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 here. All right, so here's cosine. So that's cosine of x. We're wanting to graph secant. Okay? All right, so what am I going to do? Wherever cosine is 0, what are we going to put? An asymptote. An asymptote. All right. Wherever cosine is 1, we're going to flip away from that. That's where we're going to put all of our hills or like our parabola looking things, right? And you're going to see now why I did. So now all we got to do is erase the pink graph to have secant. Okay. Now the question is, what do you want to keep? That's the $60 million question. I've done it 2 ways. I've kept 2 different 1 cycles, right, where the start and end are. I have a preference, even though the math might be a little bit harder, I have a preference of what I would want to keep. So we're going to leave this picture for a second. All right, now I'm going to just erase the pink cosine graph so that we can now focus solely on secant. But now you can see how to get it. All right, there's your secant graph. There's no right, as long as you get, first of all, what's the period gonna be? How far before it repeats?
2 pi.
2 pi, it is 2 pi periodic. The question is, what do you want to keep? We may disagree, it's okay. I have a way I like to teach it. I think you've got two things you could keep. All right, you could do this. You could do 0 to 2 pi, just like cosecant, but you got like half of a parabola, a down parabola, half a parabola. I think that's a pain. What I like to do is this. I like to keep the same picture. See, cosecant is the same picture as cosecant, just shifted left. Start with an asymptote, middle's an asymptote, end's an asymptote. The only problem is it's at negative half pi and 3 pi over 2. If you're okay with that, then we'll use it. Where is this going to become a difficulty, do you think? What might be a pain about this start and this end? The phase shift. Because you got to set bx minus c equal to negative pi over 2 and bx minus c equal to 3 pi over 2. But that's how I would do it. Because that's that picture that you want to repeat. I know I got stray marks all over, but I think you can at least follow. So let's put this there. So I would do secant. Now you can see why I did cosecant before secant, because it's a much easier one. So for secant, I would go 0 to pi, I would go negative pi over 2 to 3 pi over 2, and it's the exact same picture. I'm just shifting left half a unit, or or 1/2 pi. So it just takes you a while to get start, middle, and end, right? There's that. And then period is still 2 pi over the absolute value of b. And then if we want to do the secant of bx minus c, we take bx minus c, set it equal to negative pi over 2, and we take bx minus c and set it equal to 3 pi over 2, and that's how we get the new start and new end. Now, let's just do one problem, all right, for secant. Let's see if we can figure out, let's do this. Let's do y equals 2 secant of 4x, and let's just see if we can sketch one cycle, okay? So what is the 2 going to do?
Vertical.
Yeah, it's going to multiply the y's by 2, it's going to stretch it. So I would just, so for me, I would just, when we go to draw it, I'll move those instead of 1 and negative 1, I'll do 2 and negative 2. And we're going to take 4x and set it equal to what? Yeah, and we're going to take 4x and set it equal to, and then, Andrew, what did I say I like to do? I'm not going to divide by 4, I'm going to do what? Yeah, that's just me. You don't have to do that, but I think it's a lot better. Okay? Go ahead and see if you can get the start and end, and then we can draw one cycle, and that will end today's lesson, and that allows you to get started in here if you like. And it is open. It's open in the course compass. So probably I think you'll just put period, and I think you may have to put, I don't know what it'll ask you for secant. You may have to put, it may ask you for like vertical stretch. You may have to type in a 2 or something. Okay, so what do I get here? I'm gonna, instead of dividing by 4, I'm gonna multiply by a 4th. So we get that the new start is negative pi over eighth, and then again, multiply by a fourth. We get the new end is 3 pi over 8. Well, since this is negative power of 2 and 3 power of 2, it's the same type of incrementation. 1 unit to the right, and then the power 8 will be there, and then the 3 power 8 will be here. There's that. And then I'll go ahead and do the 2, right? And the negative 2. And it goes an up, and then it goes a down like that. Okay? But it's nice, the computer helps graph it. What would have happened if this was a negative 2? Yeah, it would have been down here, opening down, right? So you gotta rotate it about the whole X. Okay. That's a lot. Let's stop there, okay? We are done for today. We will resume on Monday. Bye.